Thank you, everybody, for coming to today's webinar. We're really excited to have you join our expert panel presentation today. So after a brief introduction to why we're sharing this webinar with you, we're going to be diving into noise, indoor air quality, and excess soil. There's going to be an opportunity to ask questions between each of these topics, and we're going to go through the housekeeping on that shortly. But as you may be aware, the World Health Organization is celebrating 75 years this year, and World Health Day is in just 2 days' time on April 7th. The theme for this year is Health for All. And as an environmental health and safety company, ECOH, which stands for Environmental Consulting Occupational Health, we really believe in health for all. And this year, we're celebrating 23 years of protecting people, property, and planet. We have 2 service hubs in Canada, Mississauga and in Ottawa, but we also serve clients across Canada and beyond. Amongst our 75 employees, we have many professionally accredited staff, and we serve a wide variety of industries, as you can see on the screen here. Ultimately, our aim is to provide customized solutions for your health and safety challenges. So we have 3 presenters today. They will each be touching on a different topic under our theme, as you may have seen from our introductory email. Protecting people from noise will be Michelle Mendoza, Senior Occupational Hygienist. Protecting people and property in the context of indoor air quality is Lisa Scolaro, ECOH's Director of Health and Safety. And protecting our planet from misuse of excess soil will be Praveen Gurukar, Vice President of Environmental Services. So before we jump into our content, just a few quick housekeeping items I've got here. So all attendees will be muted for the duration of the webinar, but there will be an opportunity to verbally ask questions at the end of our overall presentation. Please use the raised hand function at the end of the presentation, and we'll be happy to unmute you. There's also opportunities to ask written questions. So if you look in the top panel of the Zoom bar here, you'll see Q&A. So if you just click on that, you can enter questions at any time and pop them in there, and our wonderful facilitator, Chanel, will make sure that they are answered by our experts. If you run into any technical difficulties at any time, leaving the meeting and returning typically will resolve these issues. But if it persists, then let us know in the chat or send us an email at learning@ecoh.ca, and we'll do our best to help you out. The presentation will be recorded, and we're going to upload that to our YouTube channel. So we'll email you the link to it within a few days of the webinar. And lastly, but not least, we'd really appreciate your feedback. It'll take about 3 minutes of your time to fill out a quick survey, just with your comments or any suggestions. The link will pop up on the webinar screen after it ends, and that would be amazing. So without further ado, I'd like to introduce our first speaker today, Michelle Mendoza, a Senior Occupational Hygienist that we're proud to have on the ECOH team.
Good afternoon, everybody. So as Gnomes kindly introduced, my name is Michelle Mendoza. I'm an occupational hygienist here with ECOH. And beside me here is Taylor, our other occupational hygienist. So we're going to be sharing this presentation about noise. So what is noise? Noise and sound, we use those terms interchangeably. Noise is typically unwanted sound, and sound is what our ears hear. Sound is a type of energy made by vibration. So when an object vibrates, it produces waves, and these waves travel through a medium, usually air, as well as water, until it reaches our ears. And our ears have special receptors called hair cells, and these are what interpret those sound waves into the different sounds that we hear every day. The human ear has a wide, can detect a wide range of frequencies from 20 to 20,000 hertz. So that's quite a wide range, but most of our everyday sounds are coming in the ranges between 250 to 6,000 hertz. Sound exposure occurs everywhere. It can occur continuously, intermittently, or by like impulse. So say you drop a plate on the ground, or you're banging something on a hammer just every once in a while. So age and exposure to loud sounds can decrease our ability to hear different frequencies. Noise is a very common occupational hazard. In 2022 alone, the WSIB paid out 28% of their claims, all related to noise-induced hearing loss. So I'll briefly pass it over to Taylor, and she'll speak to you about noise and different health effects.
Yeah, thanks, Michelle. So I always find that it's helpful to put things into perspective, especially with noise where it's not necessarily as intuitive of how loud is loud. So we have everything in reference to our occupational exposure limit here, which Ontario is 85 decibels. So if we start towards the lower end of the scale, things like a ticking watch will be about 20 decibels, while a refrigerator hum in the background is about 40. As we move into normal conversation and the washing machine, we get up to 60 to 80 decibels. And we finally start getting pretty close to the exposure limit where we have, say, a gas-powered leaf blower, which would range from 80 to 85. Now, moving past the exposure limit, we see motorcycles have an average of about 95 decibels. And as we all know, fireworks are pretty loud and they range in about 140 to 150 decibels. So the health effects of noise can be broadly divided into two separate categories. We have the auditory, which are the more well-known health effects, but also non-auditory effects. So the auditory effects we generally see are tinnitus, which is ringing in the ears, a temporary hearing loss, which generally recovers within 48 hours of exposure, and finally permanent hearing loss, which is also referred to as noise-induced hearing loss. So this is hearing loss where once it's gone, it won't return. Now, we also have non-auditory health effects, which are less well known, and these can include things like increased accident and error rates, reduced productivity, insulin resistance, stress-related ulcers, cardiovascular diseases such as coronary heart disease and hypertension, as well as things like sleep disturbance and annoyance. And I'll pass it back to Michelle.
Thanks, Taylor. So there are some chemicals that impact our hearing. These are called ototoxins. They can either worsen or cause hearing loss. In the workplace, there are over 100 substances that are considered ototoxic, and there are also medications that are ototoxic. So just to give you a couple of examples, some pharmaceuticals, including certain antibiotics, diuretics, painkillers, and cancer medications can be ototoxic. We've also got solvents such as carbon disulfide, toluene, asphyxiants, nitriles, metal compounds such as mercury and tin. So most of these ototoxins you would probably be exposed to in the workplace, if you have it, that is. So Taylor already alluded to an 85 decibel limit. So where do these regulatory limits come from? So in the workplace in Ontario, the regulation is 381/15 noise, and it tells us that you should not be exposed to over 85 decibels over an 8-hour shift, or if you do, then you need to be implementing some type of hearing protection or hearing controls to reduce that noise. In our environments and in our local communities, there are also occupational noise limits. We've got the Ministry of Environment and Climate Change, so they have their environmental noise guideline, and that gives establishments a limit of how much noise they can produce to their adjacent neighbors, and that can range from 40 to 60 decibels, and it depends on the type of industry as well as where that establishment is located. And of course, our local municipalities have their own bylaws about noise. So you can see here on the screen, in the city of Toronto, there's no noise from construction during after hours as well as on the holidays. We can also pull some guidelines from different well-known established associations, such as the Acoustical Society of America. So they have very good design practices for reducing noise, say in a music room versus in a cafeteria or in an auditorium. And they have recommended limits for reducing the amount of reverberation time, which is the amount of time an echo is required to dissipate. And we've also got the World Health Organization, and they have established some guideline limits for sound levels with respect to road traffic, aircraft, railways, and wind turbines. So how do you know if your workplace is too noisy? So you can do a noise survey to measure what the noise exposure is. We can do that with a sound level meter. So that's that item on the left with a little black circle up top, or you can use a noise dosimeter. So a sound level meter, we typically use those to measure how loud either a piece of equipment or an area is, whereas a dosimeter, we use those to measure an individual's exposure to noise. And you can get some sound level meters and dosimeters that can even break down the loudness of similar frequencies, and that's considered octave band analysis. So how do we control noise? So you've figured out that, say, your workplace or a certain area is quite noisy, then we can do that in a number of ways. So looking at the hierarchy of controls, you can eliminate the hazard by removing the source, but that's usually very difficult in a workplace setting or even, say, in the community. So we go down that list and then we can think about substitution. So maybe we can reduce the noise by replacing with a quieter piece of equipment. If we can't do that, we typically run into engineering control. So that could be dampening vibrating surfaces, installing acoustic barriers, enclosures, reducing the fan speed. So those are some options. We can also look into administrative controls. So that would be doing routine maintenance on your equipment. So making sure if anything is worn or loose that they get replaced on a regular basis, making sure that equipment is well lubricated, testing parts to make sure that they're not running off balance, as well as developing a hearing conservation program. And the last way we can control noise, not the ideal way, but sometimes it's the most practical way, is to implement personal protective equipment. And in this case, that would be earplugs and earmuffs. So just going to quickly go over hearing protection devices. So like I said, earplugs and earmuffs. Earplugs, very convenient, very small. So they can either be reusable, disposable, but they do take time to insert properly. And you shouldn't be using these in areas where the sound level is over 105 decibels. We also have the option of earmuffs. So those are good for attenuating, which means reducing the sound for low frequencies. And they're good because they typically fit most sizes, but they can interfere if you're wearing glasses or other type of PPE. In some circumstances, you can also combine both. So you can be wearing earplugs and on top of that have earmuffs. So it's kind of hard to see on the earmuffs there, but there is a little number that looks like 101, and that is the noise reduction rating. So hearing protective devices do come with a noise reduction rating, and that's the amount of noise attenuation that these devices can provide. But you just need to be cautious that these are based on laboratory conditions, so in like ideal settings. So if you do run into using hearing protection, you do need to make a calculation to determine what the actual noise attenuation is in the real life setting, and you can see that in the CSA standard. So how can ECHO help when it comes to protecting people from noise? Well, we've done several hundreds of noise surveys for a variety of clients, manufacturing settings, offices, schools, law enforcement, healthcare, and as well as the community. And we can help you determine like how loud a work area is by conducting those noise surveys, as I mentioned earlier, determining which areas are noisy or even which tasks are noisy, seeing which workers are overexposed to the noise limits or whether or not they are, and many more. So yeah, got questions. So yeah, questions.
Thanks so much, Michelle and Taylor. If anybody has any questions specifically on this this section, please pop them in the Q&A panel at the top. I just guess to kick that off, I actually had a question, Taylor. I found it really interesting when you were talking about non-auditory impacts of noise on health. I'd never really thought about that before, but I suppose to kickstart our question and answer period, can you give me more information about the insulin resistance? How does noise actually impact the body and insulin?
Yeah, for sure. That's a really great question. So it's thought that the relationship between noise and insulin resistance really comes down to stress. And by stress, we're meaning any sort of unpleasant or unwanted stimulus. So as Michelle previously alluded to, noise is an excellent example of this. So this stress activates an area of the brain which is called the amygdala, and the amygdala is involved in the body's fight or flight response. So over time, our amygdala learns what sounds are associated with potential danger. So when that happens, the amygdala will release stress hormones like cortisol, which is helping our body prepare to either fight the condition or get out of the condition. And one of the ways that cortisol works to prepare our body is by reducing the effect of insulin. So instead of insulin signaling for any excess blood sugar to be taken up and be stored for later, say when we go to exercise or we haven't eaten in a while, cortisol actually signals for it to be kept in the bloodstream so that it's quickly available should we need it to fight or get out of that area. And when this cortisol insulin battle happens over a long period of time, we run into the issue where not only is less insulin produced by the body, but it also becomes less effective. And this is what's known as insulin resistance. So that in turn, over long periods of time, may increase someone's risk of type 2 diabetes.
Super interesting. I had never known that before. Thank you. Chanel, do we have any questions in the panel box here?
No, there is no questions at this moment.
Awesome. If you guys do have any questions, feel free to put them in at any point. But in that case, let me introduce you to our next presenter, who will be sharing one way that ECHO can help protect your people and property, specifically around the context of indoor air quality. So thank you, Lisa. She is our Director of Health and Safety. Looking forward to it.
We go. All right. So thank you, Naomi and Michelle and Taylor. So I'm going to continue on with our theme today and speak a little bit about indoor air quality. When we look at indoor air quality, it pulls in two components of our theme today. So looking at protecting the health of people that are working within those buildings, as well as protecting the actual property, so that actual building. Okay, so protecting it from issues of poor air quality, maintaining our ventilation systems, protecting from mold and water intrusion, just to name a few things. So today I'm going to touch on a few things related to indoor air quality, specifically the idea of sick building syndrome, and how that ties into the overall air quality within a building, as well as what we call the 4 Ps of indoor air quality. So the 4 components that come together to influence the quality of air within a building. So we'll start with sick building syndrome. So this is something I'm sure you've heard of, be it via social media, news, looking at the web. But this is a very real syndrome that many people speak about. So when I say very real syndrome, if you look at that first bullet there, it's actually defined, sick building syndrome, as a variety of non-specific health or comfort related symptoms that seem to relate directly to time spent in a building. So when I say non-specific, there's a very long list of issues or complaints that a building occupant may have. So they may range from headaches to respiratory systems to just general feelings of unease or fatigue. So they really are non-specific, and the only thing that ties them to that building is the fact that the occupants feel those symptoms specifically with time spent in a building, and they tend to alleviate when they leave the building. So on the evenings and in the weekends when they're not actively sitting in that building. Many times there's not a specific illness that can be related to this. It's just those non-specific symptoms that somebody is experiencing. So tying that into indoor air quality, many times sick building syndrome, an investigation can be completed, and it can be tied to a variety of different things that could be influencing the way a person feels. Okay, so it could be certain chemicals in a building. It could be physical things. So Taylor and Michelle talked about noise, could be that, could be lighting. It could be a biological agent. So it could be mold. It could be a certain bacteria. So a very wide range of things that could be influencing the indoor air quality and ultimately causing sick building syndrome. So to speak to indoor air quality, it is defined by the U.S. Environmental Protection Agency as the air quality within and around buildings and structures especially as it relates to the health and comfort of building occupants. So it is directly tied to the air quality, both within and around. Now, when we talk about acceptable air quality, there are some definitions that we use. We like to use the one from the American Society of Heating, Refrigeration. Easier shortened to ASHRAE. So they define acceptable air quality as air in which there is no known contaminants at harmful concentrations as determined by cognizant authorities and with which a substantial majority, so about 80% or more, of the people exposed do not express dissatisfaction. Generally speaking, acceptable indoor air quality is as close to outside air quality as possible. And in our indoor air quality assessments, we use carbon dioxide as an indicator to comparing those two. So that brings me to the 4 different components of indoor air quality. So I'm going to talk briefly about each one. So we call them, as I said, the 4 Ps of IAQ. So the first portion of this is about pollutants. Okay, so when we look at indoor air quality, we look at the presence of any pollutants that may be present in the building. So there's 4 different types of what we consider pollutants that could be contributing to your air quality. So the first would be what we call the general IAQ parameters. So this would be carbon dioxide, particulates, volatile organic compounds, carbon dioxide, temperature, and relative humidity. Okay, so these tend to be the parameters that link to the comfort of a building occupant. The second type of pollutant is your microbial. Okay, so this could be your mold, bacteria, Legionella, or it could also be pest pathogens that may be present in the building as well. The 4th pollutant is in the gas form. So this could be any type of, let's say, chemicals that are used in the building for maybe production. It could be formaldehyde, which could be off-gassing from furniture, carpets, could be paint, could be ozone from photocopiers, it could be sewer gas, could be a variety of different things. And then the last type of pollutant is your particulates. Okay, so combustion products, any kind of lead, silica, dust, anything that's in particulate form would be a type of pollutant as well. And you'll see we've also linked that into the general indoor air quality. So you'll see that particulates is mentioned there as well. It is one of those comfort level parameters that we measure. So that's why it is mentioned twice. So moving along to the second P of IAQ. So this is speaking to the pathways, which essentially is how air moves and travels within the building. So you can see we have a variety of different pictures up here. That very first one is looking at an HVAC system and basically acknowledging that we are moving air through these systems and throughout the building. So pathways throughout the building could be, simply through vents and diffusers. We have stairwells and elevator shafts that are great pathways for air to move. And then looking at those last 2 pictures on the bottom there, we can see that we have holes or penetrations in walls. These also act as pathways for air to move throughout the building. So just keeping that in mind, that air is moving in many different directions, not necessarily just following what your ventilation system is aligned to do. So very much tied to the pathways is our third P of IAQ, which is pressure. The idea of pressure is the fact that any kind of air movement, which includes any odors and airborne contaminants, basically flow from areas of high to low pressure. Okay, so you can see in this schematic here, we have the air diffusers that are basically pumping the air into this room, and the air is moving to areas of low pressure. So be that exiting your cold air returns, leaving through windows, leaving beneath doors. It's basically trying to find the area of low pressure for it to move to. And then just to tie the last piece in is the fourth piece of IAQ, which is people. So people play a very, very important part in indoor air quality. So they act as basically two things. So the first being the receptors. So people are the ones that complain of indoor air quality problems. They're the ones that are affected by it. And they act as the receptors. However, people are also the source of many pollutants. So generally, you know, when we exhale, we are releasing carbon dioxide. We wear scented products, which sometimes are a nuisance to others. We carry viruses and bacteria on our bodies. And we shed skin and hair cells, which contribute to particulates or dust in the workplace. So we're also the source of the indoor air quality. Now, tying into that is many times not all workers are going to be influenced or affected by all indoor air quality parameters. Many times it's just a handful of workers that are sensitive, but it's enough to trigger concerns over the quality of indoor air. The other thing is that people tend to be quite fussy. So we come to work, we expect our office to be clean, to be, you know, have lots of nice fresh air. We expect them to be better than our homes. Okay, so we more readily complain about dirt and poor air quality in our office spaces or our workspaces than we would at home. So how can we help protect your property and your people within buildings? So we have a wide variety of staff that are well experienced and have completed hundreds, if not thousands, of air quality assessments. So we have completed them for many different types of buildings, everything from offices to residential. Okay, we do indoor air quality for healthcare facility, for industrial facilities, and our approach is basically we tailor our indoor air quality assessments to the needs of your workplace. Okay, recognizing that a residential space is not going to have the same requirements as maybe an industrial setting. So we work to create a tailor-made solution for your indoor air quality needs. So that may mean testing for different parameters, comparing to different regulations, and providing you with a comprehensive report on what we have found and some recommendations for moving forward. Perfect. Thank you.
Thanks so much, Lisa. That was really informative. Do we have any questions popped in the panel at the moment?
Nothing that I'm seeing right now.
Cool. So I was just going to comment from my perspective, because I've worked with Lisa before, and I've worked with a bunch of different air qualities for different clients, and some of them help for LEED certification. I just wanted to ask you about that, Lisa, in terms of, you know, if someone's looking to get LEED certified or to maintain a LEED certification, what kind of process do we go down for that?
Yeah, for sure. So interesting that you mentioned LEED. So LEED has its own set of indoor air quality guidelines. So I guess I'll start by saying that there's really not a specific legislation that says your indoor air quality needs to be a certain parameter. Now, we do follow certain guidelines. We do have Ontario Regulation 833, which speaks to various specific chemicals, but on a whole, there's numerous different guidelines, LEED being one of them that we would follow for a particular building. So we do LEED surveys, which would be following those LEED criteria to determine maximum levels of certain parameters, really dependent on what LEED asks to do. So yeah, if that makes sense, Naomi.
I think so, yeah.
We do also have one question that just came in.
Yeah.
So we have an anonymous attendee asking, is there any regulation for doing airborne exposure assessments?
Yeah, so it depends. We do follow Ontario Regulation 833 for exposure. So that would be based on specific chemicals that have particular occupational exposure limits in that regulation. So we would sample specifically for those contaminants and compare those to those regulatory guidelines. Yeah.
Awesome, thank you.
All right, thanks so much, Lisa. And again, if you have any questions about any of the things Lisa talked about or anything else related to IAQ, feel free to pop them in the Q&A and we will get to those. So I want to introduce our last presenter for today. And perfect. This is Praveen Gurukar, ECOH's Vice President of Environmental Services. He's going to be speaking to us on excess soil and why it's important to manage it properly for the health of our planet and some of our regulatory responsibilities.
Good afternoon, everyone. Thank you, Naomi. So in line with our theme of the webinar today, I'm going to talk about excess soil. I'm going to cover some of the topics on excess soil and give you an overview on what is excess soil, benefits of excess soil management, regulatory responsibilities, and how ECOH can help with excess soil management. So what is excess soil? Excess soil is defined as soil that has been excavated as part of a project and removed from the project area. It is essentially soil that has been excavated and removed as part of construction or development projects that cannot be repurposed on site. It is intended for a beneficial reuse, ideally within the local geographical area. It is seen as a resource and not as a waste. For example, if you're excavating and removing soil to reduce the concentrations of contaminants to accommodate redevelopment of a commercial property to a more sensitive land use like a residential property, then that is considered as excess soil, as that soil can still be repurposed elsewhere in a less sensitive land use like a commercial or industrial property. It is estimated that approximately 25 million cubic meters of excess soil is generated in Ontario every year from construction activities. Just to give you an idea, that is approximately 2.5 million truckloads. Majority of these soils is sent to landfills or relocated inappropriately or illegally dumped, causing adverse impacts to the environment. On the other hand, landfills in Ontario are reported to reach their maximum capacities in the next 12 years, based on the current landfilling rate. So how can implementation of excess soil management help? So implementation of excess soil management will optimize the reuse of excess soil for beneficial purposes. It will help reduce excess soil being sent to landfills. It will reduce illegal dumping and inappropriate relocation of excess soil, reduce mining of new soils and aggregates, reduce carbon emissions from soil transportation, and reduce adverse environmental impacts to the planet. Other than this, there could be potential cost savings from reducing wear and tear of roadways, transportation costs, and landfilling costs. So the excess soil regulation is being implemented in 3 phases. The first phase came into effect on Jan 1st, 2021, which included implementation of reuse rules and excess soil reuse standards. The second phase, which included implementation of excess soil reuse planning requirements, came into effect on Jan 1st, 2023. And the third and final phase of implementation will include restriction on depositing clean soil at landfill sites, which will come into effect on Jan 1st, 2025. So the excess soil regulation puts majority of the responsibilities on 2 key roles. The first one being project leader, which is defined as person or persons in charge of planning and implementation of a project. For example, if it's a municipal infrastructure project, the municipality or a representative of a municipality will be the project leader. Or if it's a high-rise development, the developer will, or a developer or a representative of developer will be the project leader. The project leader will be responsible for overall planning and implementation of excess soil management. He'll be responsible to retain a qualified person to manage environmental liabilities, implementation of tracking system for excess soil movement, and filing a notice on the excess soil registry. The project leader could pass on some of these responsibilities contractually to a third party, but the owner still lies with the project leader. The second key role is the qualified person, a professional engineer or a professional geoscientist as defined by the regulation. The qualified person is responsible for managing the environmental liability of the project and to oversee and complete regulatory requirements like assessment of property use, and if required, sampling and analysis plan, soil characterization report, and excess soil destination assessment report. A QP or a consultant cannot be a project leader because the QP is not the decision-making entity for a project. There are other responsibilities associated with a reuse site. For example, the operator or a stakeholder of a reuse site will have responsibility in terms of storage and management of excess soil at the reuse site, making sure the excess soil is reused beneficially, and in some cases, filing a notice with the registry. The regulation does not require a QP be retained for a reuse site. However, as a good practice, it is recommended that a QP be retained for a reuse site to make sure that environmental liabilities are properly managed. The filing of notice to the excess soil registry needs to be completed by the project leader before moving the excess soil from the project area. It includes preparing supporting documentations, in particular the environmental reports completed by a QP. There are some exemptions stipulated in the regulation for certain cases where preparing of the documents and filing of the notice is not required. I'll not be discussing all the exemptions here, but some noteworthy ones are exemptions on low-risk sites, like agricultural sites, residential sites, institutional and parkland sites are exempted in terms of reuse planning requirements. There is also exemption for excess soil volume of less than 100 meter cube, as long as the excess soil is taken directly to a landfill site. There's also exemption for commercial properties when the volume is less than 2,000 metric cube, except, of course, if it's an enhanced investigation property, like an industrial property, gas station, or a dry cleaner, or auto service garage, then this exemption does not apply. Again, the enhanced investigation property could be exempted if a record of site condition has been filed with no risk assessment. There is also exemptions for infrastructure projects where the project leader is also the operator of the reuse site, and the excess soil is ultimately reused in another infrastructure project. So how can ECOH help? ECOH has professional engineers and professional geoscientists who are recognized as qualified persons by MECP and can assist both the project leader as well as the operators of the reuse site to manage their environmental liabilities. We can help optimize the scope, cost, and timeline associated with the excess soil management in the early planning stages of the project and make sure that the project is compliant with excess soil regulation. We can also provide consultation with MECP for compliance with excess soil regulation and on any exemptions that could be applied to the project. Finally, what are the key takeaways? Soil is a limited natural resource, and we need to protect it for a better planet health. Excess soil management will help optimize the beneficial reuse of excess soil and help the environment. It is important to consider excess soil management requirements and retain a qualified person at the early stages of planning a project to optimize the scope, the cost, as well as the timeline of the project, and to maintain compliance with the regulation. And that is the end of my talk. Thank you.
So much, Praveen. I definitely learned a lot there as well. Chanel, do we have any questions specifically for Praveen?
We do. Okay, so the first question that we have is Sajadin. Sorry if I mispronounced your name. They did ask, is OREG 406 fully enforced now?
Hi, Sajad. Not completely. The first and the second phase of the implementation has been completed. The third phase, which is regarding restrictions on the quality of excess soil that can be sent to the landfill, which will be implemented on Jan 1st, 2025.
Perfect, thank you. And then we have Louis Aspar asking, in a recent air sampling for mold, we found in indoor project area K-tium raw content 3 4% more spores M3 40. For previous results, how can we relate it to serious health questions by the presence of K-tium, and what is the amount or quality that is considered high risk?
So this one sounds like a question for Lisa.
Yeah,
did that make sense to you, Lisa? Can you see that question?
I can see the question. So I guess it's important to, we didn't touch on it, but there's actually no regulatory limits for mold. It's any sampling results are interpretation by a professional, which can include comparison between indoor and outdoor, comparison between control areas in buildings and outside of inside buildings to your contaminated area. So I wouldn't actually take a value, and I wouldn't be able to tell you what level you could have health issues, because every person is different as well. What I can say is that Chthonium is what we call an indicator species, in that it's telling us that there are some water intrusion issues or potentially some hidden mold. So for me, phenylketonium tells me that, you know, there's still some mold present, or there is mold present that probably should be dealt with. But I would not be able to take a raw count and tell you how serious of a health effect that would be to a building occupant.
Thank you. Also, while we have you, we had somebody mention a little earlier that certifications like LEED and WELL are considered during building construction and during the first occupancy, but there will not be effective follow-up on indoor.
Yeah, so yeah, LEED and WELL, there's FitWell, there's the BOMA certification as well. They tend to have a heavier focus during construction or renovations, basically before occupancy of that building. Now, many of them do have the potential where you can get maintenance credits by doing regular indoor air quality inspections. In particular, LEED looks at total VOCs and carbon dioxide measurements for continuing maintenance. But that's correct. Many times the actual IAQ piece comes pre-occupancy with minimal follow-up and maintenance.
Awesome. We did have one anonymous attendee who asked, what is the expression QP or QE? So I'm guessing that could be for Lisa or Praveen.
Yeah, QP is defined as qualified person, and it's basically as per the regulation, has to be a professional engineer or a professional geoscientist licensed in Ontario.
Awesome, thank you. And then we did have Halitha Hannah ask, why do project consultants refuse to have QP as part of their team?
That, Praveen, that might be one for you. I'm not sure. I'm not sure of the answer to that.
Sure. I'm not very, I don't understand the question properly, but the project consultant, as per the regulation, need to require to retain, or they need to retain a QP. So I'm not sure what the question is. Can you repeat the question, Shana?
Why do project consultants refuse to have the QP as part of their team?
I don't think they refuse to have a QP as part of a team. It's just that, is it required or not? Before the regulation, sometimes it was not stipulated that QP is required. So now the regulation makes it very clear that a QP is required to do certain tasks and manage certain environmental liabilities. So that becomes, moving forward, that becomes a requirement.
Awesome, thank you for that. And then we had one more question from another anonymous attendee. How frequently industry should conduct airborne exposure assessment, lead/silica should be conducted?
So there's, to set a frequency, there's nothing specific, but you do need to do that initial assessment to ensure that you're not exposing your workers to anything. So, I mean, there's nothing that says specifically, but you do need to ensure that you're not exposing your workers. Now, tying in lead and silica, you're now talking to designated substances, which actually have, they have their own regulations under the Designated Substance Act. So there are some guidelines that you would find in that, which is 49009.
Thank you. And then Halitha has come back and said, I believe it is a liability issue. I believe talking about the consultant or the QP on the project. I'm not sure if you had any extra comments on that.
Sorry, the liability issue, I mean, again, I think this is in reference to the QP being retained for a project?
Yes.
Okay. So yes, there is definitely a liability in terms of the regulation, where that's one of the reasons why they have a QP take on responsibilities on environmental, reports and the requirements of the regulation. So the liability obviously needs the QP to be licensed in Ontario and to be a professional engineer or a professional geoscientist. So that puts the liability on the QP.
Awesome. So that's what we are currently looking at from our Q&A section. Feel free to raise your hand if you did want to verbalize any of your questions, if you still had any, or you can submit them into the chat or the Q&A section still.
Thanks, Chanel. Yeah, I'll just leave it open for a couple more minutes here because yeah, we have a few minutes for questions. And just, while you're thinking of those, this is just a little note that you can get in touch with any of our presenters today about anything that they spoke about or any other environmental health and safety, occupational hazard questions that might be top of mind at any point. Is there, any other questions at all from anybody, or chats or concerns or anything like that? Okay, that looks like about it. Thank you everybody so much for attending. Oh, we've got one coming in here.
Yes, so this one is from Tunde, and they ask, does regulatory surveys of occupational health indicators serve as a reliable benchmark for specific facility measurement comparison?
I'm just sorry, I'm looking at the question. I'm not 100% sure. I understand what they're asking. I mean, if you're going to do regulatory surveys, it's going to definitely, for your due diligence, it is gonna set a benchmark, so you can track over time your levels that you're measuring with those surveys. You can see where you're making improvements, where you still need to do work, if that answers the question.
That sounds good. And then we had another question asking, can ECHO be hired as a QP?
Definitely. We have professional engineers as well as professional geoscientists licensed in Ontario, as well as recognized by MECP. So we can definitely help with any projects that requires QP.
Perfect. Looks like that's all I'm seeing right now.
Perfect. Okay, let's close it up there. Again, if you do have any questions, feel free to reach out to any of our panelists today. Their information is here. And like I said at the beginning, the recording will be uploaded to our YouTube channel, and I'll send the link out to you all within the next few days or early next week. So thank you again for celebrating World Health Day with us in our webinar. Hope you have a wonderful rest of your day, and please do fill out the survey if you can. Thank you, everybody.